So I sometimes feel that talking about mobile now is a bit like talking about PCs in 2000, that this enormous thing has now happened and we're thinking about what we can do with it. And so I think the first way to talk about this is to talk about deployment. So if we look at a snapshot of the world today, we're about halfway to connecting everybody. There's about 5.5 billion people on Earth over 14. There's close to 5 billion people with a mobile phone. About 2.5 billion people have smartphones, and that will go to 5 billion smartphones. And so what's happening is that the mobile S-curve is passing the PC S-curve. We have about 1.5 billion PCs on Earth, and you can see that growth coming up over the last couple of decades and now flattening out and starting to decline. And then you can see how first mobile and now smartphones have accelerated past that, heading towards pretty much the entire global population. And so then if you sort of systematize that, what tends to happen in technology is that each new technology follows an S-curve and is then replaced by another one. And in the early period of that S-curve, it begins as a crazy idea, and then it becomes something that's growing very fast, and there's a frenzy, and there's bubbles. And then you move from the kind of the creation phase to the deployment phase, where the questions are much more around scaling and maturity. And then over time, then there will be another S-curve that comes after that. And mobile now is making that transition from creation to deployment. And so what that means is that the issues that matter are changing. So when we were in the creation phase, we talked about platform wars and we talked about the latest handset and argued about technology. And there were millions or tens or hundreds of millions of users. And the key questions were sort of, is this going to work and who's going to win? And now we're in the deployment phase, the winners are clear, and we're in a phase of kind of steady incremental improvement, that each phone is a bit better than the one before. A lot of the technology becomes commodity, and we're at a phase where we have billions of users. And so the question now is, well, what can we build with this thing? What can we build with this amazing, enormous thing that we built that everybody now has? And so then to think about the things I'm going to talk about in this presentation, I think there's a couple of elements to this. Firstly, we have a new kind of scale for technology, and we have new kinds of computing. And those two things together give us new ways that we can change other industries. And I'm going to go on and then talk about a couple of those industries, first e-commerce and then cars. So to talk about a new kind of scale, first, the obvious observation, we've had a changing of the guard, and the new guard are a lot bigger than the old guard. So the new dominant companies in tech are Google, Apple, Facebook, and Amazon, GAFA for short. And they're about 3 times the scale of the old dominant companies in tech, which were Wintel, that is to say, Microsoft and Intel. And so they're about 3 times the size in revenue terms, and that's pretty unsurprising. But I think what's more interesting, if you go on to the next slide, is to think about how you compare the scale of the dominant companies today with the scale of Microsoft and Intel back in the 1990s when they were changing the world. So we have this period of very rapid growth now. How does that compare to the period of very rapid growth in the past? And so back in the 90s, Wintel grew their revenue 14 times and they looked amazing. But if you compare that to the scale of Google, Apple, Facebook, Amazon today, they have 10 times the scale. So they're much, much bigger than Microsoft and Intel were back in the days when they were changing the world. If you think in terms of valuation, back in 1995, when Bill Gates was on every magazine cover on Earth, Microsoft was actually not the biggest company on the stock exchange. Today, Google, Apple, Facebook, Amazon, and yes, Microsoft are the five biggest companies on the stock exchange. So we've gone from being kind of important companies to being completely dominant companies, to being much bigger, much more powerful, much more significant companies. Now, that change in scale means much more investment. Annual capex across these companies has gone from $1 billion in 2000 to $34 billion in 2015. It also means many more people, 10 times more people, now over 500,000 people employed. And what it really means, I think, fundamentally, is that the tech giants today have a completely different character of scale to IBM or Wintel before them. It's not just that they're bigger, it's that they're giants in the economy rather than just giants within the tech industry. And also, and I think this is also very important, we have 4 of them and not just one. So it's not IBM, it's not Microsoft, it's Google and Apple and Facebook and Amazon all competing with each other. And so you have things that flow out of that. So Apple is the 10th largest retailer on Earth by revenue, with over $53 billion of sales last year, which is not bad for a marketing operation. If you then look at content, and remember the days when content was king, well, for Amazon, content is just a lever to get more Prime subscribers and sell more soap powder. They don't even care about content as a primary method. And Netflix, of course, is a content company, but Netflix itself has the 4th largest production budget in the USA. So you have tech companies impinging at a fundamental level on other industries. And there's a great quote from 2010, the chief exec of Time Warner said that thinking of Netflix as a threat was like thinking that the Albanian army was going to take over the world. I suspect he probably wouldn't have that attitude today. Then to look at another sector again, Intel's whole business of making chips has become an add-on for these companies. So Google is making custom FPGA chips for machine learning. Amazon is making custom ASIC chips for networking. Apple makes the SoC, the system on a chip inside the iPhone. It's the fastest SoC that there is on the market, and it's making all sorts of other custom chips for its other devices, whether it's Touch ID, AirPods, or other things. And so again, you have this thing that was like the center of the whole tech industry and the core to competing, now becoming almost a side project for other technology companies as the scale has grown. And so what's happening here is that we're building on scale. We're standing on the shoulders of giants. So we have the scale of 5 billion mobile users with this vast supply chain of 2 billion devices being sold every year. We have the scale of the winners in this environment. Google, Apple, Facebook, Amazon have much greater scale than Intel had before. And then we have new ways to compete, whether that's custom hardware, retail, distribution, content, potentially in the future, cars as well. And so we have these enormous giants giving us shoulders to stand on and build all sorts of other things. Now, in the meantime, we have the new thing, or the new thing, which is machine learning. And I'm not going to give you the technical explanation. I have colleagues who produce material around that. Here, really, I'm thinking about what are the implications of machine learning for the broader tech industry and for industries outside technology. So a good place to start is this image, which is a test from ImageNet. Is there a dog in this picture? And after 50 years of work, computer vision systems could get this right 72% of the time, more or less. And there's a whole class of similar problems, as we all kind of know, where there are things that are very easy for people and hard or impossible for computers. And this was really one of the focuses for research into AI. And the general consensus around this kind of stuff was that there were decades of more work before all of this stuff would really start working. And then in 2012, machine learning started working, and then really everything changed. And so for image recognition, the best results were getting a 28% error rate. Those went to 7%. For speech recognition, the best results were getting a 26% error rate. Those went to 4%. Similar results across a whole class of problems that people had been working on for decades. Performance has completely transformed. This stuff started working in a way that it had never really worked before. And to understand what happened there, it's really worth thinking about a fundamental change from using rules to using data. So the old way that you would build something to recognize a dog was you'd build something that looked for ears and noses and legs and fur, and you'd hire linguists and you'd write grammar rules and you'd try and codify how human intelligence works, which is kind of difficult because we have no idea how human intelligence works really. And then the new way that we do this, which, as I said, all started working in 2012, was machine learning, where you use data. So you give it 10,000 pictures labeled dog and 10,000 pictures labeled no dog, and you let a neural network work it out. And you let the system by itself work out what the key criteria are, what the ways of deciding and choosing and analyzing are. And so hence we call this learning, because it's the machine that's actually learning by itself. And this becomes possible because we have millions and millions of times more computing power and millions of times more data than we had when anyone tried to do this in the past. And so what that means is best summed up by this quote from Frederick Jelinek, that every time I fire a linguist, the performance of the speech recognizer goes up. And so what's happening here is that we're analyzing data, we're not looking for dogs. And so this works for many other data sets. You can ask which of our customers are going to churn. Is that car going to let me merge? Is there anything weird happening on our network? What are the patterns inside of this information that I haven't thought to look for? You have a generalizable solution. And so to give an extreme example, Google took the system that it used to win AlphaGo, the Chinese board game, in the spring, and applied it to managing or optimizing the cooling in one of its data centers. And it achieved a 15% energy saving after Google having spent decades trying to optimize that by hand. So what we have here is a way of building systems that can find patterns in data in similar ways to the ways that people would have found that data, but at massive scale. Hence this statement from Sundar Pichai, chief executive of Google, that we will move from mobile first. Google will move from mobile first to AI first, that everything in the tech industry is now being refocused from mobile to mobile plus AI. And there's a whole bunch of use cases, or indeed a whole bunch of ways of thinking about what the use cases might be, because it's still very, very early. I think the fundamental thing is that any data set can have new analysis applied to it. Secondly, that this opens up all sorts of opportunities for interaction, because now computers can look at images or video or voice in completely new ways, and that enables new devices and new interaction models. A particular thing that I want to pull out is to think about images, to think about computers being able to read images. And then, of course, there'll be a bunch of surprises. There will be a whole bunch of things that don't actually look like machine learning use cases, but that turn out to be just that. And so this also happens at the top and the bottom of the stack. So you train your machine learning models at vast scale in the cloud with huge amounts of data. But once you've created that model, you can very often put them on very small, very cheap devices. So you can run them natively on a smartphone, but you can also run them on something even smaller. So you could make a $10 or $20 widget with a camera and a machine learning running on a DSP that could look for people, or could look for cars, or could look for some specific use case. And so that becomes particularly interesting when we think about imaging, because one of the things that the smartphone supply chain has done is make image sensors available for almost anything. So you can see here the size of the global camera market. You really have cameras in absolutely everything, except, of course, in cameras. The orange line here is the camera market itself, which is now sort of shrinking down to a kind of professional rump. But the image sensor itself becomes this universal thing that can sit in anything or can apply to any kind of image problem. And I don't think we quite know what it means when we say that computers can kind of read images in ways that they've always been able to read text. We don't quite know what the implications of that might be. So as we build all of this stuff, we have this sort of surge in complexity, and we also have a rush to abstraction. And so what I mean by that is that on the one hand, we're going from the kind of the fundamental scientific insight to building an enormous amount of engineering as we work out, well, what is the right kind of machine learning to solve this particular problem? As we build all of the kind of the implementation and the product and the kind of the execution on top of the underlying concept, even as the science itself has much further to go. So both the engineering and the science are both moving at a very, very rapid speed. In parallel, we have Google, Amazon, Microsoft, IBM, other companies putting this into the cloud and making it available as a platform to other people. So you can take the speech recognition that Amazon uses for Alexa and you can plug it into your own product using an Amazon cloud product. The same for Google, the same for Microsoft, the same for IBM. On the one hand, you have this huge increase in complexity of what is possible and what's being built. On the other hand, you also have, again, the GAFA competition trying very hard to make that available as a simple layer to anybody else at the same time. What I think is really going on here, again, to return to the S-curve, is that machine learning is almost at the beginning of the creation phase. And so we're having this explosion, this frenzy of creation and invention and discovery and argument about who would win and what would winning mean, with an awful lot of low-hanging fruit and an awful lot left to build. One of the things that enables then to think about the next section is new kinds of computers or new kinds of computing. And so there's an obvious and boring point to think about mobile, which is apps of one. Smartphone apps are now 60% of all time spent online in the USA. We all kind of know this. We've talked about this an enormous amount. And that also means increased concentration. So 15 to 20% of mobile time spent is actually happening inside Facebook, which makes it the world's largest mobile web browser. There's increased concentration. It's harder to break out. It's harder to become a breakthrough app. It's harder to get to lots of users. We kind of know all of this. I think what's more interesting is to think about a new generation of computing that's happening as a result of this. So on the left, you have the original Apple Mac. We didn't really change that for 30 years until we went to smartphones. You had a keyboard and a mouse and a screen, and you kind of move your hand somewhere over on the right, and an icon moves, or a cursor moves somewhere over on the left, 2 or 3 feet away. And then we go to smartphones, and we really change a huge amount. We have this device that's intensely personal and that's always with you, and that has imaging and a screen as a primary input, that has touch and tilt and sensors and an app store, where very often you can ignore bandwidth and you can ignore battery, and I'll talk about that in a moment, where of course you're 1,000 times faster, you have a cloud, machine learning, and of course much easier to use. At a fundamental level, you have this new computing model that is both much more sophisticated and much easier to use at the same time. And that enables, on the one hand, a wave of new sensors and inputs and interfaces, machine learning, all kinds of new products that can be created. On the other hand, it enables all kinds of new creation, live, social, broadcast, touch, imaging, all sorts of things that a consumer can do with a device that they could never have done with a PC. A good illustration of this, I think, at the moment, are all of the current crop of live video apps. And I think it's interesting to think about how many assumptions live video breaks. You assume a high-quality camera, 2 high-quality cameras, assume a GPU that can do live image recognition, that can do live effects. Assume a touch screen, assume it's always on, always connected, assume it's always in your pocket, assume it knows who your friends are. Assume unlimited bandwidth, assume unlimited battery, and bear in mind roughly half of all smartphone use happens at home, so you can plug it in and you're on Wi-Fi, so you do have unlimited bandwidth and battery. Then also assume, and this is an inverted point, assume there are a billion high-end smartphones. So for 15 years, people in mobile have always said, oh, well, remember not everyone has a high-end phone, then remember not everybody has an iPhone. Well, there's a billion high-end smartphones on Earth now, so a lot of companies actually can just assume everyone has a high-end smartphone. And so what you're doing here is you're turning the whole phone into a camera, or turning the camera into a computer. And so you're really breaking all sorts of interface assumptions around what you could build on a PC or what you could have built on a mobile phone in the past. At the other extreme, you have kind of frictionless computing, I think, in devices like Alexa, the Amazon Echo, or Snapchat Spectacles, where you don't have any buttons or any apps or any intermediate steps. There's no cable. You don't have to think about charging it, really, or it's charged for a week. There's no computer stuff, no clerical work you have to do, no admin you have to do before you use it. And I think what's interesting about these devices is that they're not just a camera or a microphone or a speaker. They're actually unbundled pieces of apps. So the Amazon Echo is the unbundled Amazon app. The Spectacles are the unbundled Snapchat app. And so you're moving that app into a new context. And of course, they're all built with commodity components from the smartphone supply chain. There's no unique hardware technology in any of these things. And then you light them up with machine learning. And so you have the sensors, which is a smartphone or the smartphone components. And then you layer machine learning on that, speech recognition, computer recognition, whatever else it is, and then whatever it is you actually want to do, the action on the end of that. Now, one should sort of hesitate just for a moment and remember that just because you can recognize what somebody said doesn't mean that you can do anything about it. So you have to narrow the domain to the things that you can actually do and work out how you can tell your users, actually, I can do this, but I can't do that. And I think that's one place where Amazon has been very successful with Echo and perhaps more successful than a bunch of previous voice assistants. But when you've done that, when you've removed that friction, you're also you're removing friction and you're changing choices. And I think it's interesting to think about the kind of direction of travel of computing as being about removing questions. So do you have the printer driver? What's your password? Where did you save that file? Do you want to restart the computer? Do you want to turn it on? Do you want to turn it off? Do you want to plug this in? Well, these are all kind of questions that we don't think about anymore that computers used to ask us and that the first plug and play and then smartphones got rid of. Well, if you ask Alexa to order you soap, does it ask you what kind of soap? Does it ask you what app you want to use? If you take a picture with Spectacles, does it ask you what app you want to share it with or who you want to send it to? You're removing friction, you're removing questions, you're removing admin. And of course, as you remove those questions, you're also removing choices. And so that creates a huge strategic incentive for the big platforms, particularly for Google, for Apple, for Facebook, and of course, for Amazon above all, to be the ones who can answer that question. And so these kind of devices and these applications and interfaces create all kinds of new questions as to who it is that actually owns the customer and who it is that's going to be the one that answers that question for you. But I think really at a kind of a fundamental level, what's going on here is a direction of travel. And so it used to be that you would have kind of direct physical interaction with data. You would actually hold the data in your hand. You could make new zeros with a pin. You were holding the ones and zeros in your hand. So we've gone from direct physical interaction with data on the one hand to direct physical interaction with data quite at the other extreme. Now you're touching it, you're looking at it, you're talking to it, you're holding it. The next generation, as we move to augmented reality, you'll just be looking at it and waving your hand at it. And so you have direct physical interaction from one extreme to a complete opposite extreme. So all of this gives us shoulders of giants to stand on. New computing, new scale, new interaction models, new ways of interacting with computers. I'm now going to talk about two ways that changes things that are not actually technology, that change other industries. And the first of those is e-commerce. So I think it's useful to think about retailers as newspapers. That is to say, newspapers had a fixed cost base with falling revenue. And they shifted from a paid model to a freemium model. Their entire product got unbundled. Their fundamental distribution advantage disappeared. And as we went to a new medium, you had different consumption. So it wasn't just that you read the same things in a different place, you read different things. And just with e-commerce, it's not just that you buy the same things in a different place, you buy different things. And so conceptually, I think what I would say is that everything that the internet did to media will happen to retail. So you break up on old bundles and aggregators, whether that bundle is an album or a magazine or a newspaper or a store or a shopping district or a mall, they're all aggregators and bundles. And then new aggregators emerge, and those new aggregators shape consumption in different ways. They result in you buying things or consuming things in different ways. So far, what e-commerce has done is give you the stuff you already knew you wanted. You know that you want to buy that thing, so you can go on Amazon and get it. And so today, e-commerce is about 10 to 12% of US retail revenue. A little bit more in some other countries, a little bit less in some others. Amazon is at least 2% of that. If you include marketplace revenue, it might be 4% or even 6%, depending on your estimates. But so far, e-commerce has been much better at logistics than at demand generation. It's been much better at retail as logistics than at retail as experience or at suggesting what you might want to buy. That said, it's got to almost every product category. So 15, 20 years ago, people were saying, well, no one will ever buy clothes online. Today, Amazon is the fourth largest clothes retailer in the USA. Not the fourth largest online clothes retailer, the fourth largest clothes retailer. So people will buy anything online if they know that it exists, particularly with free returns, which is just another piece of logistics. The question is, how do you know about it? So how do you know what you want to buy? Amazon is Google for products. That's where you go to find something. We don't have Facebook for products, not Facebook in the sense of friends, but Facebook in the sense of all the suggestions it gives you for random stuff you might want to look at. We don't have BuzzFeed for products. We don't have working, viable, systematic, scalable ways of suggesting things and discovering things. We have a lot of great, interesting companies trying. That's not a solved problem where there's one great company that does everything. And so what that means is that the internet lets you buy, but it doesn't really let you shop. It lets you buy anything you could get in New York or London or Tokyo. It doesn't let you shop the way you can shop if you live in New York or Tokyo or London. Now, the first response to this, first way of digital demand generation, is advertising. And the advertising industry, together with marketing globally, is about $1 trillion every year. $500 billion spent on ads, of which about a third is on digital, and half of that third is on Google, and then another $500 billion going on marketing. So end caps, coupons, promotions, discounts, everything else, ways of getting people to buy things. But then when I look at that chart, and I'm reminded of the line from Jeff Bezos that your margin is my opportunity. I rather suspect that advertising is an opportunity just as much as margin is an opportunity. And so I think what happens here to Channel, Marsh and McLuhan is that one should think that the channel is the product. So as you change where you buy things, you change how you buy things. You buy different things in a supermarket, from a grocery store, you buy different things online, because again, the channel shapes what you want to buy. And so there's two examples to think about here. One of them is what you might call soap as a service. That is to say, you ask Alexa to get you more soap, or you buy an Amazon Dash button and you put it in your washing machine. You never make a brand decision again. You don't decide what soap to buy anymore. You've made that decision. So you've disintermediated Walmart, but you've also disintermediated an ad agency. And in a sense, you've also disintermediated Procter & Gamble, who are, among other things, bundling chemicals up with the brand and brand equity and distribution. So you're completely changing the whole journey of how that soap powder gets from a chemical factory to your home, and why that brand rather than another brand gets to you. At the opposite extreme, our portfolio company, Walker & Company, building a men's grooming product, is able to build that and take that to market in ways for an enormous amount less money than it would have cost you in the offline days, because of the amount you have to spend on promotion, the amount you have to spend on inventory, the amount you have to spend on distribution has been completely changed. So on the one hand, you can totally change something with a dash button. On the other hand, you can take a conventional product and just sell it in a different way online. But I think if we then go a step further and think about machine learning and how that applies to these kinds of questions, how imaging applies to these kinds of questions, we get some other kind of interesting opportunities. Now, what would happen if you were to buy the last 10 years of L decoration on eBay and drop that onto your neural network, and then take a photograph of your living room? What might it be able to suggest? Would it be able to tell you what sofa you would like, what cushions you would like, what lamp you might like? Those are things you could never do with computing in the past. We kind of know how you might do that with computing today, whether that's for clothes, for makeup, for travel, for cooking, whole categories of products that are around personal taste and around what you see and what you think you would like, rather than just the things that you already know. What would I like that I've never seen? Well, today you have to go to a store or look in a magazine. You need some kind of manual editing or curation. We may be able to do that in completely different ways in the future, with imaging, with machine learning in particular. And so a canonical quote here, I think, from Eric Raymond: a computer should never ask the computer for anything that it should be able to work out by itself. Well, what will the computer be able to work out? What do you want to buy? What questions will it be able to answer for you again? Or what suggestions will it be able to make? I think one of the ways of thinking about what's happening here then is that data is working its way through retailing. So in the 90s, we had computing coming into the supply chain with ERP and completely changed that part of the industry. In the 2000s, we have advertising, certainly at least digital advertising, giving a little bit more data as to how you think about how people buy stuff. But what's really going to happen now is we think much more about demand, about how you choose what you might buy. Because with digital, as you go online and as you add imaging, as you add e-commerce, as you add machine learning, you start having completely new ways of thinking about what you might want to buy. So if we then pull back to 1980, here are some more S-curves. So this is the S-curve for Walmart. And Walmart, of course, used new technology to change retail. It used trucking and refrigeration and computing and various other things in order to change what retail would look like. Amazon is just starting to do that now. We will see more S-curves as we use new technology again to change how retail would work. And if one then thinks about the scale of the opportunity here, this chart shows you some of the sectors that have been upended by software today: consumer media, mobile phones, perhaps pay TV, perhaps TV production. But if you then zoom out, retail is something over a $20 billion opportunity. And all of that is potentially going to be affected by software, by machine learning, by e-commerce, by mobile. So there is shops to think about, from small cardboard boxes flying around the world to think about very large metal boxes speeding around the world with cars, from one extreme to the other. And so if retailers are newspapers, cars are definitely phones. History doesn't repeat itself, but it rhymes. And so for phones, as for cars, today's technology moat disappears. Key components today, key points of differentiation today become commodities. All of the value moves to software. Network effects move away from the hardware into software and into the cloud. And the word phone and the word car mean something completely different. And I'm going to talk about all of these in turn. So first, as we disrupt cars, as the tech industry disrupt cars, there are really two almost completely separate paths. The first is electric and the second is autonomy. And the move to electric is happening today. And what electric does is that removing the engine and the transmission totally destabilizes the car industry and its suppliers. Moving from gasoline to electric is not about taking the gas tank out and putting a battery there. It completely changes how the car gets made. It doesn't, however, change how the car gets used very much. Autonomy changes that as well. And so autonomy is in its very early stages today. It is perhaps 5 to 10 years away. There are an awful lot of challenges to resolve, one after another. But when autonomy works, it changes the value. Of course, it accelerates on demand, but it changes what cars are and it changes cities probably as much as cars themselves change cities. So to talk about electric first, the shift to electric is about the battery cost curve and about a function of battery economics starting to work. Right now, battery per dollar per kilowatt hour is something over $200. As it gets down closer to $100, it becomes completely cost substitutional with gasoline. And so that just is a question of time. As you move to electric, you unbundle the car. And so your complex proprietary gasoline engines and transmission systems disappear and get replaced by much simpler commodity batteries and motors. And so this whole central spine of the car that was where all the money and the investment and the differentiation was, that all just goes away. And you have 10 times fewer moving parts. And the whole basis of competition in making the car goes away. It's not about the gasoline, it's about the engine and not having an engine anymore in the same way. Now, that doesn't mean that everything changes. So scale, design, brand, distribution still matter for people who can navigate the change, but a huge amount of value moves up the stack into the software, and which is an entirely new skill set. And then as you go to autonomy, you get new layers of value being built on top of this. Now, a great precedent for thinking about this, again, back to the phone analogy, is what happened to phones. And so back in 2000 or 2001, you had to have co-invented GSM to make phones. And all of the technology and the invention was in the cellular. It was in how you talk to the network and in understanding that. And so Nokia said that manufacturing was a core competency. That was a fundamental competitive advantage. 75% of all Nokia phones were made in 8 factories, and they had 40% of the market. They dominated the world. Today, Apple's iPhone has 189 suppliers, 789 locations. None of those are owned by Apple. A small number of those components are unique and distinctive and created by Apple, but an enormous amount of that has nothing to do with Apple at all. And the whole component supply chain of the phone industry got completely unbundled, which is why you now have not just hundreds, but in a purely literal sense, thousands of companies in China making mobile phones. Then to think about the scale here, this is kind of an unfair but relevant comparison. Leading technology companies are now spending as much on CapEx as car OEMs. These are big companies. Apple, meanwhile, has $237 billion in gross cash on its balance sheet. Google has $73 billion. So questions of scale and engineering and bashing metal are entirely accessible to new kinds of companies. So there is electric. Now as we think what happens as we add autonomy to this, there is a set of steady steps or steady progress towards autonomy. And this is kind of the standard industry terminology from level 1 through to level 5. Level 1 is the cruise control that your grandparents' car had. Today, we are at the stage of building cars that can more or less stay in their lane and more or less slow down, but you've really got to be sitting in the driver's seat ready to take control and watching the wheel all of the time. That's a car that will probably have fewer accidents, but it's not a car that can drive itself. What we move towards is level 4 and then level 5, the car first where the driver can sit in the back seat, but the car might have a problem. And then level 5, where you don't have a steering wheel and where a commercial vehicle might have no cabin and might not have a human involved at all. And that level 5 is probably 5 to 10 years away, with the emphasis on 10 years, depending on who you talk to. Now, at the point that you do that, you start thinking, well, what's the competitive moat in cars here? We should presume that batteries and sensors will become commodities. So where are the strategic levers? Well, there is a clear strategic lever in physical scale. Bashing metal is still about physical scale. Design, manufacturing, there is a lot of expertise and difficulty in that. But then as you move to the software, well, there are network effects. There are network effects in the driving data to feed your machine learning engine. There are scaling and network effects in the possession of your high-density 3D maps that the cars need to move around. It's not yet clear how many winners there will be in this, or even who the winners might necessarily be, but there are very strong network effects. And then with on-demand that you can layer on top of that, again, there are strong network effects, a virtuous circle of a density of cars and density of riders, which tends to support Uber and Lyft as opposed to anyone trying to create their own on-demand fleet again from scratch. But really for all of these are unanswered questions. It's so early that it's not yet clear quite what the answers to these will look like. When you have that, though, when you have autonomy, talking about a self-driving car, a term I deliberately haven't used until now, A self-driving car is a bit like a horseless carriage. That is to say, you take the horse off, but that's not really the only thing you change. When you've taken the horse off, then you change everything else about the vehicle. And the same thing with both electric and autonomy. When you take the gasoline engine out and you take the steering wheel out, you will change everything else about the car. So we will have completely new kinds of vehicle types. We will also have completely new ways of using those vehicles. And so what that means is we can kind of focus on the obvious impacts of this stuff, which are oil and safety. It's easy to talk about those, that half of global oil production goes for gasoline for cars, and 1.25 million people are killed every year in road accidents around the world. But those are the obvious things. The second order effects, if anything, would be much bigger. So what happens to the industry and servicing cars if you have 10 times fewer moving parts? What happens to the machine tool industry? What happens to power generation and storage if all those cars are electric? What gets sold in the 150,000 American gas stations if nobody's going and buying gas anymore? What happens to taxes? But then when you look at autonomy, if every car on the road is fully autonomous, there's no more parking and there's no congestion, or there's much less congestion. Every car can drive down a freeway 2 feet apart from the car in front of it. What happens to housing in that environment? How far are you willing to live? What happens to logistics and retail? What happens to commercial real estate? What happens to trucking if you don't need a driver? What happens to the ownership of cars? What happens to insurance? Really, one should think about autonomy changing cities as much as cars themselves change cities in just as many unpredictable ways. If we'd been having this conversation 100 years ago, we probably could have said that everybody on Earth would have had a car, although half the people in the room would have said you were crazy to suggest that. But we wouldn't have predicted Walmart, and we wouldn't have predicted freeways. We wouldn't have predicted all the other changes that happen to cities as a result of cars, for better and for worse. And so where I think that takes us is that the biggest changes here are probably unknowable. This is an illustration from the year 1900 of what going to the opera in the year 2000 would look like. We have flying cars. Nothing else has changed. We have Paris in the year 1900 with flying cars. And that tends to be the fallacy that people make in looking at the future, that our current society will go into the future totally unchanged, except that we'll have robots or flying cars or computers. A housewife will have a robot to do the dishes for her. And that tends not to be how it works, and that won't be how it works for autonomous cars as well. Thank you.